Welcome back to the shop. It's good to see you again. Like a lot of people, I shoot my videos on an SLR, and which is fine, fantastic, cracking pictures off these cameras. However, when you get to a certain age and you need the spectaculars, the screen on the back here, I don't think is big enough or good enough. It doesn't show you everything that I think you need to see, and it's just a bit small. The other thing is the batteries that these cameras run on don't last very long. So join me after the titles and I'll show you what I intend to do about that. So here we are at the bench, and this is really the crux of my video setup. Apart from the GoPro that you're watching from, I've got an old Canon EOS 600D, which is long in the tooth, very much like me. I've got two lenses, a wide angle and a telephoto, and some extension tubes which you use with the telephoto to give you some real close-up stuff. Absolutely fine. That does nearly everything that I want. It's a pain changing the lenses, but so be it, really. However, the batteries don't last very long, and I've got an adapter on this one that takes two batteries. And the LCD screen on the back is, I don't think, big enough. It's really quite difficult to tell when you're in focus. It does have a zoom command, so you can zoom in, but it's just a real pain. So several years ago, I bought a monitor. And this is an HDMI monitor that will literally plug into the camera, and you can see a much bigger screen. Fine and dandy. But I've never really used it. I made some adapters to mount it to my tripod, but it's such a faff to set it up. You really want something easy, something quick and easy. So I got to thinking, the batteries don't last very long, need a new monitor. Perhaps it's time I designed some system that would mount this by the camera and also power it from one of these. This is a small one. It's a Makita 3 amp hour 18 volt lithium ion battery. I've got loads of these in different capacities, but one of these should make this camera last for hours and hours and hours and drive the monitor. So I'll show you what I've designed. So this is my Franken camera. Let me turn it upside down and we'll start on the bottom. At the bottom here is a plate that is threaded with 1/4x20 and 3 8x16 holes right down the middle there. This is borrowed from professional camera setup. That is the mounting point for a tripod, basically. And at the back here, we have a Makita battery in a slide. Let me turn it around so you can see that. There we go. That's a Makita battery that slides in and out, and that's going to power the whole thing. However, in order to power it, these are 18 volts and the camera here runs on 7.2. So I needed a little electronic box. So I've got in here is a little circuit that DC to DC converter that's powerful enough to drive the camera. So the power will come in, go through here, which is a fuse. That's an on-off switch. This is the connector for the power to go to the camera. On the other side are two more sockets. One of those is going to drive the big viewfinder monitor I'm going to use, and the other one is going to drive an LED bar graph. But more of that in the next episode. And on the top here, just briefly, is a USB port. So it's all hopefully quite self-explanatory. It's a simple setup, but it's still, there's a lot of work involved. So let's get on with it. So here we go. This is the first part I'm going to start. It's the plate that mounts to the tripod and everything else gets bolted to it. So let's get on. Job's a my coolant was stopping flowing, and then when I looked at it, the tank here, the filter tank, is absolutely full. The coolant is not going through the filter. God dearie me. It's not particularly full of stuff. There's a spider in it, but that doesn't look too bad, to be honest. I think I'll clear this out and take out the fine filter that's in the bottom, the really fine one. I think that was probably okay for coolant and soluble oil, but I think that's probably blocked with the machine oil that's pumped into the waves of the machine. Right, here goes. Let's pour some of this back in and see if it works. This is how I intend to machine this. The camera plate is attached to an L bracket. That L bracket is aluminium and has been machined flat, so it is perpendicular to the spindle, and the plate is held in place with two machine toolmaker's clamps, and I've also added the repeating stop, if you like, for the vise, so I can take this out and put it back in. So the first operations is to do all of the holes in here and chamfer them, and then I can take the plate out, or take the whole assembly out, drill a couple of holes through, put some bolts through, then put it back in the mill in exactly the same position, and then do the contour around the outside. Tool change, go. Okay, that took 3 minutes and 6 seconds. I've just set the height of the tool because I don't have a tool library as yet. So that's now 14. The tip of that spotting drill is 14mm above the surface we're going to work from. So I've said Z is 14. So I'm going to go G0. Z50, that'll go up to 2 inches above the surface. If I zero that, then I can run the program in the full knowledge that it won't actually touch the surface. Should be okay. I will let it run this cycle just to make sure. That's the spot drilling done. Now I need to go through the outside holes here. More likely it's going to drill a hole straight in the bottom of the part and break the drill off. What was all that about? I've had this a couple of times with this mill. There you go. It thinks Z is 40mm above the surface, and if I can just hold on the remains of the drill, there we go, that actually is buried in the surface. I don't know where that error comes from, but it is frustrating because everything was hunky-dory when I did a test run. So for some obscure reason it's lost. It's plunged in by about 5 or 6mm. Anyway, I'll put a new drill in and we'll have another go. Okay, we're ready to go again. So cycle start. Now what is going on? I don't understand that. That's buggered that up even further. It's marvellous. It's just getting better. I don't know what's going on with this machine today, but it was absolutely fine with the milling, but absolutely terrible with the drilling. So look, I don't know if you can see that, but it's bent and broken another drill. The last hole, it stopped in the hole. Once it drilled all the way through, it stopped, and then tried to move the table over to its reference, which is over there. So consequently, the drill was still in the hole. It's got nowhere to go but break it. It should have retracted. So I don't get that. I don't know what's wrong, what setting I've got in this thing that's not right, but it needs looking at. Anyway, but it's resurrectable, that's the main thing, because this plate is 10mm thick and it only needs to be 8mm thick, so I can surface it off and take out all of these gouges, assuming I don't make them too much deeper. Right, first operation is to see if I can get the piece of broken drill out of the hole. There's a bit of it. Come on. How about that? This plate is 2mm or so thicker than it needs to be. So I reckon that surfacing it will get rid of most, if not all, of those marks. These holes are going to be 1/4 by 20 and 3/8 by 16, which is the two standard threads to hold cameras onto plates, etc. And I'm power tapping these, but because I can't, there's not enough room to get a tap to spin round, so a tap handle. So I'm going to do it like this. It's quick, but I have to say I'm not a huge fan. It's just too easy. Yeah, it's just too easy to break a tap. Here we go. After a bit of fiddling and faddling about, I've put 2 stainless steel countersunk M5 screws in that don't go all the way through, which is handy because I can then countersink them this side without too much difficulty, and I can skim the top of this off. Now that can go back in the mill and get on with it. After doing the contour, I don't know if you can see that particularly easily. It's not a bad finish, but it's got some striations on it. So I'm going to run the code again, but this time to go full depth and just round once. Get that out of the way as much as I can. Right, I'm doing this blind. I've not run this code and tested it. So let's hope. Okay, breaker tool. Yeah, I think that's going to be fine. Right, so I've run the path again, and I reckon that that's not going to get any better than that. That's good enough for what I want out of it. Not brilliant, but good enough. Right, I'm now going to put a fly cutter in and just deck off the top a couple of times until I've got rid of these extra holes that I drilled in. Yeah, fine man. However, I am going to put the flood coolant on, so we won't be able to see. That is superb. All of the uglies have gone. The extra holes that I drilled in and scraped, they've all gone. And we are about 1/3 of a millimetre thicker than we need to be. So when I flip it over, I've got enough meat to just take a very light skim cut the other side. So I've changed to, can you see that? I don't know. I've changed to a spot drill, which I'm going to use to chamfer the edge just round here. I've decided that I'm going to put the countersinks in on the drill press, because I just think there's something not right with how the thing is drilling, how this mill is drilling. So I'm probably best off to do it by hand. Oh yeah, that's putting in a fantastic little half millimetre chamfer all the way around. Perfect. I can't tell you how satisfying this is. I came in this morning to make another part for my camera sled on the mill, and I've turned her off now, but the power drawbar didn't work, so I thought, so I've been around the back and I'll show you. The O-ring has failed in the bottom. It's not coming out the top. That's as dry as a bone, and it's not coming out of the union fitting there. It's coming out, excuse my computer while it boots up, it's coming out of there. So I'll strip out the power drawbar, because I can still use the machine. I just need to change the tool manually with a spanner, which is tedious, but still works. So I'll take that off and put it on the bench, and I'll show you what I think I'm going to do with it. Here's the complete power drawbar. That only took 10 minutes to get it off the machine. So this is the drive power or master cylinder, and it's not leaking at the top, but if you look down at the bottom here, you can see that it's leaking hydraulic oil. When I built this, I made a little nipple to fill it, so that is how you get hydraulic fluid in, and there's a major problem with that. My theory was that if you cycle the whole system a few times, the air bubbles will make the way to the top and you can just keep filling it up. However, it takes such a long time to do that it's a bit of a pain. So I think what I'm going to do is fit some more nipples. These are car brake nipple replacements, and basically if you've trashed your brake cylinders, you can re-tap them M10 by 1, thread this in, and you've got yourself another brake. You've rejuvenated your brake cylinder. Absolutely fine and dandy. These were cheap. I think about £3 or £4 each. What I'm going to do is fit one of them in here somewhere, and the other one in the top here. So I can't get on with that, unfortunately, because I'm still waiting for the tap. I ordered it 3 weeks ago and it's still not here, so I've cancelled that order and ordered it from somewhere new. So you may say, before we go any further, you may say, well, how does this help? Well, it's really simple. If this nipple is in the bottom here, I can put the power cylinder down to the bottom of its stroke, i.e. close off this cylinder completely, pump hydraulic fluid straight in, and in theory I should be able to fill the entire thing in a matter of minutes rather than a good 3/4 of an hour. This is the camera riser block, and we'll get on with that next. As you can see, it's not a particularly complicated part. Another blade bites the dust. They don't last, these things. They really, really don't last. Yeah, every single one of these blades, I've gone through probably a dozen of them now, they all fracture. There's the weld. That started to fracture. There's another fracture there. Another one there. I really think I need to get thinner blades for this, but I can't find any. If anybody knows where to get really thin blades for it, that'd be great. Thank you in advance. Alright, another blade to the slaughter. for some obscure reason, I had checked the depth of cut for the last tool, and you can see it was rubbing there. So I've changed to a 4 flute, which is all I had, in 6mm. Let's press cycle start and break the tool. Hurrah! That is a much better finish. Okay, moving on. If anything, I think I've kissed the edge of that a little bit too hard. I only wanted to put a tiniest little 1/2 mil chamfer on there, and that looks like that's about 1mm, maybe 1.5 mm. Anyway, so be it. I was thinking about this last night. I've got a really nice finish on this side of the part, but if I go to the other side, you probably can't see that particularly well, but you know, forgive the focus, but there are marks in that side, and this is what I think has happened. A lot of these small mills, this one for sure, have something affectionately known as head nod. The head tilts forward slightly because the column at the back is not strong enough to support the weight of the head, the motor, and all the gubbins and the spindle and the tool, etc. So consequently the head can move slightly, and I think with a conventional climb cut and the tool rotating clockwise as we'd expect, cutting into this side of the part is trying to pull the head down further. And that's why, and it can't move, so consequently we've got a nice finish there. But on this side, I think as the tool is going around clockwise, as it should, and as we bite into this material, it tries to lift the head up. So consequently, I think that's why we've got a rough finish on this side. So I'm going to try something to see if I can cure it. So this is what I thought I'd do. I'll run the contour toolpath around here again, but I'll run it in the other direction. So in theory then the good side should be this side. So I'll do that, set up to do that, and we'll see what it's like afterwards. It could be quite interesting, I think. I reran that toolpath 3 more times in conventional milling and round this way. And I have indeed improved it. I had to move it this way, the part this way, very slightly, I think by about 0.1 of a millimetre, in order to make sure I'm cutting into the part. So it's actually slightly under dimension this way now. But yeah, I took this Nat's cock off it and it actually looks so much better. So I think I can safely say that the head on my machine is a bit wibbly wobbly. Hardly a surprise though. Most of this machine is wibbly wobbly. Anyway, I'll take this out, change the tool, and turn it over, and I'll take the top off it, take the top hat off. Yeah, excellent, we'll leave that to get on. That's not a bad finish, but this is only a roughing insert, so I'm going to change that to a finish insert. Oh, one that's designed for aluminium. Yeah, that's done. When I moved the mill down here, I accidentally broke my touch probe, so let's fix that. When I built my touch probe, I made a few spare probes and a handy dandy little chart here, a little bit of paper that tells me what the overall lengths of each of these are. So that's 8, that's 4, 7, 2. There we go. That must be number 1 that's in it then. There we go. So I've put the touch probe in the spindle and put a little DTI on the ball on the end, and we can see it's not running particularly true. So there's 4 screws in the top here that I can loosen and dial out that eccentricity. There we go. That's after 5 minutes I've got the deflection down to about a micron, I think. And let me just load the spindle up, give it a pull and a push. Look at the deflection there. I think that adds credence to the fact that this machine has got a bit of head nod. Having sorted the run out of this new probe, let's plug it in and just test it. I'm on the diagnostic page of Mach 3, and there's the digitized probe, normally active. And if I just touch the probe, it's making good, reliable connection. Good, we can move on. Have to admit it, I need the manual. I can't remember how to drive this probe software. Right, so let me try the Y direction width. So there we go, press the button and see what happens. And here are the results. It should be 60 square, this block, and it's come out pretty close. But more to the point, I've now found the centre point. I've loaded the chamfer tool and I've loaded the chamfer code. So let's see what happens. So cycle start. Excellent. That chamfer is less than the one on the bottom of the part. However, it's a much closer match to the camera plate. So I'll buy that. The next part is this plate here. It's the go-between between the camera mounting plate. This screws to the tripod and the camera screws to it. And the Makita battery adapter. That's this piece here. This is the battery that slides in from the back. So let me turn those bits off. And there we go. That is next. Right, that is not going anywhere. To the mill. Found my centre point, my G54. Let's break a tool. That's going to take 20 minutes, so I think I'll just pause it and put the GoPro in. Well, as I'm sure you've just seen, oh, go back to velocity. I've wrung that cutter off a treat. Right, as I'm just reissuing code, I'm prepared to just hit the go button. I know it's going to cost me another cutter, but hey ho. The trouble with this mill is that it's like me, it's not fast enough or rigid enough to take really heavy cuts. So here we have a home machinist in his natural environment, just waiting to put his hand in his pocket, pull his phone out and order another cutter. Right, that's it for that tool. Right, I'm going to rerun this the chamfer program because I forgot. I've got to take. I've yet to deck this surface down to make it nice and shiny and flush. No, actually, just to make it shiny. So I'm going to take about 1/3 of a millimetre off it, if not 1/2 millimetre. So I might as well put a bigger chamfer on it now. I'll do that off camera. There we go, I've finished fly cutting the top. Here we go. Give that a clean. Look at that. That's bloody good, isn't it? For a little hobby grade machine, that is really almost semi-professional. 'Tis another day and I'm going to hopefully finish this part off today. I've got a stack up of parallels in here. That means I can put this part in and clear the tiny little brim that's left that I need to face off. However, I need to find the middle of the part. So what I think I'm going to do is just slide this over slightly, clamp it in, and then touch off in Y across these two jaws. Then that will establish the Y0. Then I'll move the part into the middle of the vise and then establish the X0 by probing the ends. I've pushed the probe back that way slightly because right at the centre line, which we were parked on, is a tiny little nadger, a little ridge left over from machining the other side of this part. So I didn't want the probe to touch that because that will offset the centre point very slightly. After what feels like forever, but was only half an hour, I've determined the centre point of the part, and here I've got the actual dimensions of it. So I did this LY a few times, and it's basically 99.8. That's pretty close to 100. The X length is actually a millimetre longer than it should be. It's 126, should be 125. So that might just be an error on my part. Anyway, we're ready to go. Right, all set to take the inside pocket out. So cycle start. So that has separated the waste from the middle. When I say waste, that'll go back in the scrap bin. Yeah, and I need to go round again at a slower rate just to take off 0.1 of a millimetre. So we'll get on with that. That's looking reasonably good, I have to say. Close GK. I've got the wrong code. Back to the confuser. I should really put the computer that drives this on the network so that I can just post it to a folder and share the folder. I'm currently taking out of the code all of the tool information. So this should be tool 2 according to Fusion, but in fact I take out all of that detail, you know, tool height offset, change the tool and tool height offset, and I run every tool as tool 0 because I don't yet have a tool offset table loaded in here, and I don't have one in Fusion. And you may say, well, why haven't you? And this is why I haven't, because I've got all of these tool blanks that I haven't yet machined to take specific tools. They're all a bit filthy, to be honest, but so they all need machining to roughly that sort of shape. They've all got the right mounting spigots, so they'll fit in the mill properly, but I haven't got round to doing any more yet. Once they're all done, piece of cake. I'll record all the offsets, put them in the tool table and load them into Fusion. That's a good 3 or 4 days work, at the rate I work anyway. Program run, put the coolant on, hit the go button. We're over here at the bench, and this is the part you've just seen me make. I've got some holes to drill and tap in it, but basically that's a slide for a Makita battery, and that will fit, this camera plate will fit on top, and the camera will screw to the top of the plate. That's fine and dandy, except I don't have a mounting screw that's long enough to go through that this thick plate. So I've done myself a quick little drawing, and I've got myself a bit of stainless in the lathe, so let's go and make this. Here we are over at the lathe, and I've just necked this down a little bit so that I can turn it round and hold it. So let's just, oh, blimey, got a grip on that. There we go, that should do. Now I want that to be 20 diameter, and it's 22 at the moment, so we'll just whip a bit off. The bull gear on my lathe has got 75 teeth, and I've marked every 3rd tooth, and I think that'll give me a nice straight knurl on this thumb screw. It may not be too visible, but I've put a threading tool on its side so that I can just traverse into the work this way using the carriage and take a gouge out. And to the next one. So after about half an hour of twiddling and fiddling, I have got a knurl. So happy with that. I just need to tidy it up a little bit and just face off the end for now. That's tidied up quite nicely. It's good enough for what I need to use it for. That's, you can see that? No, you can't. There we go. Let's try it out. Right, so here we are. After a little bit more shaping, I've reduced the neck of this threaded knob so that it fits through this plate. There we go. I'll just screw it in. So basically, it can rotate, but it's captive. That's how all of these screws work. Now I need to take the overall height of this knob down so that it's below this face, because that screws to there. So that thumb screw needs to be a little bit shorter. In fact, it needs to be that much shorter. Right, I'll get on with that. And this is how I'm going to do it. I've got some scrap binium in here, which I've tapped 1/4x20. All these camera threaded attachments are all imperial, sadly. So that'll screw in there. And now I can reduce the length. There we go. However, I have to be really careful because that neck down section is weak. So if I'm not careful, I'll just rip this off. So the order of the day is light cuts. Off with that tool, and I'll put a chamfer tool in. To be honest, you'd be hard pushed to tell that that's not quite as round as it should be. We're back over at the mill, and I've put my piece of scrap binium with the knob in it, in a V block in the vise, and I've centered the mill over the I mean, it's roughly centered, it doesn't have to be that good. I'm only going to put a slot in this, so I'll change that tool to a 2mm end mill, and we'll just go backwards and forwards and zip a slot in there. I'll continue this off camera There we go, 10 minutes in, and I've cut a 1.5mm deep, 2mm wide slot. Here is the acid test. See whether I actually strip this or just undo it. Oh, look at that. Look at that. That's really good. Really pleased. So there we have it. One locking knob. I've got some holes to drill and tap in this, and some countersinks to put in here, so that these M4 screws, countersunk screws, fit flush. So I'll do all that off camera because it's just drilling and tapping. You see me do hundreds of those now. Thanks for watching. I've literally run out of time for this video. Please hit the like, subscribe, share the video, and even hit the hype button, whatever that means. And we will see you on the next one. I haven't yet finished the design for this anyway, so that's going to take me a little bit of thinking about, because I want to mount the monitor behind the camera, but also make it so that it can swing out to the side, and possibly with a little bit of a tilt adjustment as well. I haven't come up with a decent solution for that, but if anybody's got an idea, then please let me know. We'll have to pick this up at some point in the future, hopefully the next video, but if I haven't managed to figure this out, it'll be further down the road. Anyway, thanks again for watching. That was a bit of a waffle. Do take care, and we'll see you on the next one. Bye-bye.